Ladies and gentlemen, boys and girls, welcome to today's lesson on completing the square, where we'll be trying to turn quadratics into solvable quadratics. All right, so completing the square, probably one of the weirder things that we do in math, but it's actually also one of the oldest ways of solving a quadratic. Yes, older even than factoring, okay? Older even than using the quadratic formula, which, fun fact, before the quadratic formula was developed, completing the square was the way to go and solve any sort of unfactorable or non-square quadratic polynomials. And if you go and you see what the proof for the quadratic formula is, it's really just completing the square for the general case. All right, so I'm going to preference today's lesson by saying that unless you are explicitly told to solve it by completing the square, it is definitely not the most efficient way to go and solve a quadratic. However, for those of you that are going to move on to pre-calculus, college algebra, stuff like that, when you start studying conic sections, you're going to need to be able to complete the square in order to solve or evaluate or find characteristics of any conic sections. But that'll come much later in your mathematical career. Today, we're going to start just with the very, very basic, simple completing the square when you have a leading coefficient of 1. All right. So completing the square is kind of a long process. All right. But it's not a bad process. It's just a longer process. And what does that process look like? It looks like all of this. Wow. Lots of steps there. And it is, but very easily, very doable. So in order to complete the square, the first thing that we have to do is we have to make sure that the quadratic has been written in standard form, okay? That's your ax squared plus bx plus c is equal to 0. And for today, when we're just really introducing completing the square, we want to make sure that our value of a is equal to 1, all right? So for this class, that's already going to be true. All right, we're not going to throw crazy curveballs at you or anything like that. We're just introducing how to go through and complete the square. All right, so then using arithmetic, we're going to rearrange the quadratic where it's in the form x squared. Remember, because we said a is always going to equal 1 for these types of problems that we are looking at today, okay, plus bx plus blank equals negative c plus blank. All right, how do we end up with a negative c over here? Well, we had a positive c and we subtracted it from both sides. That's about it. Okay. So then what we're going to do is we are going to try and find the number that belongs here. Okay. I just call it the magic number. Okay. How do we find the magic number? We take whatever the coefficient b is and we divide it by 2. Okay. Then we take that quotient, b divided by 2, and we square that. That, ladies and gentlemen, is your magic number. And why do I call it the magic number? Because it is the number that allows you to factor your quadratic into a perfect square factorization. Okay? You'll see what I mean when we start taking a look at examples of that. Okay? So we take this value b divided by 2 and then square it, and that's our magic number. We're going to add that magic number to each side of the equation. That's why we went and drew 2 blanks there. So it's a kind of visual reminder, hey, whatever you do to one side, you also do to the other side when we're dealing with an equation, okay? So then we're able to go through and factor our perfect square quadratic trinomial, and then we're going to go and solve by taking square roots, which is what we learned how to do the other day. So in essence, if we're completing the square, we're rewriting our polynomial to something that can be turned into a perfect squares factorization, and then solving it by completing the square. All right, so it seems kind of weird. It is, but it's actually pretty cool. One might even say it's, oh, magic. All right, so first, let's go through and get some practice with finding the magic number, which, if we're using actual math speak, we would say find the value of c that completes the square. So we're trying to find what value belongs in these blanks here, okay? So we're going to find the values of c that complete the square, and then we're going to go and write it as a perfect square factorization, okay? So if we're going to go and do stuff with a magic number, then I probably need to have like a magical pin to do it. All right. So we're going to start off by taking a look at this first example, x squared minus 8x plus what? Okay. So if we go back and look at our process here, we need to go through and we've used arithmetic and arranged the quadratic in the form x squared plus bx plus blank. That's what we have, x squared plus bx plus blank. So how do we find what's in the blank? Divide the b coefficient by 2 and square that number, that quotient. That gives us our magic number. So I'm going to take this number, -8, and I'm going to divide it by 2. Well, -8 divided by 2 equals -4. And if I take -4 and square it, I get 16. Okay, you'll notice there's already a plus sign here because I know that I'm squaring, so I'm always going to end up with a positive value there. Okay, so we've got x squared minus 8x plus 16. That's the value that completes the square. Why do we say it completes the square? Well, what happens if I try and factor x squared minus 8x plus 16? Well, what are factors of a positive 16 that add up to a -8? Well, -4 and -4. So this is x minus 4 times x minus 4, which could be expressed as just x minus 4 squared. Oh, now we got it. Now I know it's called completing the square because I'm making this so that it's a perfect square factorization. Fancy, fancy stuff there. All right, so let's take a look at the second one here. We've got x squared plus 22x, okay? What value is going to complete this square? Well, I'm going to go and take my b term, and I'm going to divide that bad boy by 2. 22 divided by 2 is equal to 11. If I take 11 and I square it, I get 121. So 121 is the value of c that completes the square. And how do I know that? Well, what is 11 plus 11? 22. What's 11 times 11? 121. So could we just factor this into x plus 11 squared? I think we can. Okay. So again, this is why it's called writing the expression as a perfect square. It's a perfect square factorization. Okay. Now, hopefully you've also noticed something. Over on this first problem, we had -4 and we squared it and it factored into x minus 4 squared. Minus 4, minus 4, minus 4, minus 4. Coincidence? I think not. Because over here we have 22 divided by 2 is 11, and then we factor that, we get x plus 11 squared. So 11, 11, 11, 11. Ho, 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 ho. Looks like we got an easy way to go and write the factorization. All right. Now sometimes we may throw a curveball at you and say, oh, what about x squared plus 7x plus blank? Ooh, well, I can find the magic number. That's easy. Take 7 divided by 2, and I get 7 halves. Ugh, that's not fun. Except for it's just a number. Square it. Remember some of your rules for rational exponents? 7 over 2 times 7 over 2 is just 49 over 4. Okay, that's it. Well, how the heck am I supposed to factor x squared plus 7x plus 49 over 4? I don't know how to do that. Oh, but you do. You do, don't you? Because you know it's going to factor into a perfect square factorization. You know that first term is going to be x, and you know the second one is going to be this 7 halves. So it's just x plus 7 halves quantity squared. That's it. Okay. If you can find the value of c that completes the square, you essentially have done all of the work required to find what those perfect square factors are. All right. So now that we know how to find the value of c that completes the square, what do you say we start taking a look at some problems where we're actually going to solve it by completing the square? So we're going to take a look at 3 examples to do that. Okay, this first problem says solve the equation by completing the square. Okay, so it's x squared plus 8x plus 15 equals 0. We can see here that it's already been written in standard form, so I don't need to manipulate it in standard form. But since it says to solve it by completing the square, I probably do need to go through and move this 15 over. Well, how am I going to do that? Easy. Subtract 15 from both sides. So this is going to turn into x squared plus 8x plus blank equals negative 15 plus blank. Okay? So now I can focus on just the left-hand side and I can go through and I can complete the square. So how am I going to go and complete the square? I'm going to take this value of b here, 8, and I'm going to divide it by 2. And 8 divided by 2 gives me 4. I'm going to take that number 4 and I'm going to square it, and that is my magic number. 4 squared, 16. But this is an equation, okay? Whatever one's doeth to one side of thine equation, one must also thus doeth to thine other side, okay? That's just kind of the weird way to say whatever you do to one side, do to both sides. So we're also going to add 16 over here, okay? This is an equal sign, so we're keeping that equation balanced, okay? We didn't do anything over here that we didn't do over here. They're still equal, all right? But the cool thing is I can look over here now and say this is x squared plus 8x plus 16. How can I factor this particular function? Okay, x squared plus 8x plus 16. I'm just factoring that bad boy. All right, I can go and I can factor that into x plus 4 squared. Okay, and that will be equal to negative 15 plus 16 is 1. And now looky what I can do. I can go and I can take the square root of both sides. Okay, so I'm going to take the square root of this. I'm going to take the square root of this. And when I take the square root, inverse operation, so I've got x plus 4 is going to equal the square root of 1, remember, is plus or minus 1. Okay, so we're actually going to have two equations to solve. We're going to have x plus 4 equals negative 1, and we're going to have x plus 4 equals positive 1. So we're going to do the same thing to each one of those. Okay, so we're going to get x equals negative 5 is one of my solutions. And the other solution, I'm going to get x equals negative 3. So my solution set is going to be x equals negative 5 and negative 3. Okay, could you go and check this solution? Sure, you could plug it in and make sure it works. I'll go ahead and tell you it does. I'll also tell you, you might have looked at this problem and thought to yourself, wait a minute, wouldn't it be easier to solve it by factoring? Because 5 and 3 multiply to 15 and add to 8, and then I'd get the exact same answers. Wow, that would be so much faster. Yes, yes it would. Which is why I normally don't recommend to solve it by completing the square unless we're learning the skill of how to solve an equation by completing the square. Okay, so sometimes it takes a couple minutes to go through and do these, but it's all good because it's all basic math. Literally the hardest thing we had to do is divide something by 2 and take a square root. If you can divide by 2 and take a square root, you can do this, I promise. All right, so let's take a look at the second example where we're going and solving. So this one also says solve the equation by completing the square, but this one is a little different. Okay, it's x squared plus 14x minus 35 equals 8. So it doesn't equal 0, but I'm going to go ahead and tell you guys a little secret. Okay, you could go and subtract 8 from both sides and put it all over here, which is equal to 0. But then aren't you just going to have to go and add that number back over to this side to give you a blank right here? Yeah, so I'm going to suggest that on problems that look like this, leave the x squared term over here, leave the x term over here, but go ahead and move the constant and save yourself a step. So I'll add 35 to both sides, okay? And because I can do basic arithmetic, I know that this is going to end up being x squared plus 14x plus blank magic number equals 35 plus 8 is going to give me 43 plus blank. Okay, I added a plus blank over here, add a plus blank over there. All right, so now I'm ready to go and complete the square because a is equal to 1. This is all set up where I can find my magic number that gives me my perfect square factorization. So how do I do that? Middle term, divide it by 2. 14 divided by 2 equals 7. If I take 7 and square it, that's going to give me plus 49. Because I added 49 to the left side of the equal sign, I must also add 49 to the right side. Okay? So now I have a perfect square trinomial factorization that I can do over here with x squared plus 14x plus 49, right? Okay, it's going to end up factoring into, x plus, what's this number? 7 squared. Okay, because 7 times 7 is 49, and positive 7 and positive 7x is that 14x. Okay, and then over on this side, I've got 43 and 49, and don't use a calculator for it. Come on, guys. So if we do 40 and 40, well, that makes 80. Plus 9 is 89. Plus 3 is what? 92. Okay, so that's going to give me a 92, right? So now that I have this plus 92, I can go through and take the square root of each side, okay? So I'm going to go and take the square root of everything that's on the left, and I'm going to take the square root of everything that's on the right. And maybe I'm going to notice that 92 isn't a perfect square. Well, that's okay. Not everything can be a perfect square. It's a good thing you already know how to go through and simplify squares like that. Okay, so this ends up just being an x plus 7. So we don't need a parentheses, silly math teacher. So x plus 7, because that and that did each other in, equals plus or minus the square root of 92. Okay, so I need to go through and figure out how I can simplify the square root of 92. If I'm going to try and figure out how to simplify the square root of 92, I need to find the perfect square that it's divisible by, okay? Preferably the largest one. So I'm going to go ahead and say it's probably one of the smaller ones. So if I do 92 and I go through and divide that by, say, 4, does that one work? Yeah, I get 23 and 4, okay? So just by kind of randomly being lucky and guessing, I guessed that the square root of 92, which I'll do up here, and I'll do it in this color to show you how it's kind of a separate part of the problem, but we're still doing it. So this could be written as really the square root of 4 times the square root of 23. And 23 I know is prime, so that makes it easy. So this is really 2 root 23. All right. So if I go back and take a look at this, and I'm just gonna go over this part. We're just gonna split it up into 2 here. So we're gonna have x plus 7, okay, equals plus or minus 2 root 23. Okay, normally I'd go through and tell you to split it up into a positive case and a negative case, but I can't actually add a value of 7 to a value of 2 root 23. So what I can do is I can just subtract 7 from both sides, okay? So this is just x, and this is literally just negative 7 plus or minus 2 root 23, okay? Now, hopefully, and this is where things get interesting, you look at this answer and you think to yourself, wow, that looks an awful lot like it could have come from the quadratic formula. Negative b plus or minus the square root of da-da-da-da-da. Oh, looks like that probably came from something like that, which is why I said at the beginning of this lesson that, hey, let's keep in mind that solving an equation by completing the square is actually how they did the proof for your precious, precious quadratic formula. All right, so if we have a problem like this and we can take the square root, split it up into 2 equations, give me 2 solutions. If we end up with a radical, okay, then you can split it up, but it's not really necessary because we can just use the plus or minus sign since we can't actually add and subtract 7 and 2 root 23, okay? Leave those as exact, don't do it as a decimal, okay? So let's go take a look at one more problem, all right? So solve the equation by completing the square. X squared plus 45 equals negative 6x minus 2. Well, this one is just all jumbled up. So this and this need to be on the left, and this probably need to go on the right. So let's move this one over here, and let's move that one over there using some algebraic manipulation. I would add 6x to each side. So x squared plus 6x. Okay, I'm going to subtract 45 from each side. But I need to remember my plus blank. So negative 2, take away another 45. Well, that's going to give me a negative 47, but then I still want to have plus a blank right there, okay? So if I go and take a look at this one, All right, I've now written it in a form where I can go and solve it by completing the square. I got to find my magic number first though, okay? So how do I do that? Take the value of 6, divide it by 2. I'm going to end up with 3. Take 3 and square it, and that's going to give me a 9. Since I added 9 on this side, let's also make sure that we've added a 9 on that side. So now I have this trinomial that I've kind of created that is a perfect square factorable trinomial. Okay, let me get that exponent in there too. I was feeling left out and lonely. So x squared plus 6x plus 9 is going to factor into x plus 3 quantity squared. Over on this side, we've got negative 47 plus 9. Okay, so what is negative 47 plus 9? Well, that's going to give us a nice, pretty negative 38. Okay, I say nice, pretty, but that's anything but pretty. That's heinous. Okay, that negative 38 there is almost a guarantee that I'm going to have you guessed it, imaginary. Okay, but I can go and I can take the square root of both sides. So the square root and the perfect square are going to just take each other out, which is, kind of fun. So we get x plus 3 equals plus or minus. I know that negative is going to give me an I, so that's I root 38. Okay, is it possible to simplify the square root of 38? Okay, so go through and try and divide it by your perfect squares. Is it divisible by 4? No. Is 38 divisible by 9? No. Is 38 divisible by 16? No. Is 38 divisible by 25? No. Is 38 divisible by 36? No. And then we start getting numbers that are bigger than 38. So that's actually as simplified as it gets. Okay. So if we're going to go and write that as a solution, remember we've got a plus or minus with a radical, so we can just leave it there. We can subtract 3 from each side. So if we had x plus 3 equals plus or minus I root 38, we can just take a 3 away from each side. Combining like terms, which I don't really have any of on the right-hand side, that would just be negative 3 plus or minus I root 38. And that would be our two solutions that we would get via solving by completing the square. Okay, so we've seen an example where the numbers turn out nice and pretty. We've seen an example where we have some radicals that maybe we have to go and simplify, and then notice the answer looks an awful lot like it came from the quadratic formula, but they're all real numbers. And then we've also seen an example of how sometimes they turn imaginary. Okay, so solving equations by completing the square will always allow you to get the answer. Okay, it is not the simplest way to do it, but it is a very, very, very incredibly valuable mathematical skill that we should all have. Just remember, in order to solve by completing the square, we've got to make sure that we're talking about something that's in standard form. We want to rearrange it so it's in the form x squared plus bx plus our magic number equals whatever that value of c was after it got subtracted, or maybe added over, plus your magic number. Then we find the magic number that completes the square by taking b, dividing it by 2, and then squaring it. That allows us to go through and express this quadratic trinomial as a perfect square factorization, and then we can solve by taking square roots. So it seems like it's a lot, it kind of is, but I believe in